Let's start off with the next part, which is nature of roots. Now we know the quadratic formula, which we use to find the roots of a quadratic equation. So when we have the quadratic equation as ax square plus bx plus c equal to 0. So this is the equation, and when you find the roots, we have the formula as minus b plus minus root of b square minus 4ac upon 2a. This is the quadratic formula. And this part which is inside the root b square minus 4ac, this part is known as the discriminant, and we can also denote this by the symbol d, by the letter d, usually used to represent discriminant. So now, what is the role of discriminant? The concept is, if this discriminant is greater than 0. So you can just understand this logically. If b square minus 4ac is greater than 0, so this eventually x will have two values, right? Minus b plus minus of a root upon 2 into something. So when d is greater than 0, you'll always have two distinct real roots. And the graph of the quadratic will look something like this. So if the leading coefficient is greater than 0, then the graph of the quadratic will be this way, and the x-axis will be somewhere here. So you'll have two roots. So these will be your two roots. And if the leading coefficient is less than 0, then you'll have a inverted parabola, something like this. This is your x-axis, and these are your roots. So this is how it will look. Now, if this d is equal to 0, then you'll say that you have two real and equal roots. Or we can also say these are repeated roots. So if you understand this part, so what will happen is, see, if you see this b square minus 4ac becomes 0, so then this x will be only minus b upon 2a. There will be no plus minus left. So there will be only, in fact, there will be only one root. So it's actually a repeated root, right? So how will be the graph look like? So the graph will be something like this. This is your x-axis, and the graph will just touch the x-axis and go. So this x-axis will actually act as a tangent. So this will be the root, and this is just one root. So actually these are repeated roots. So we call it two real and equal roots. Here obviously a is greater than 0, and if a is less than 0, this will be this way. This is your x-axis. This is the root. And the last part, if you have d, if you have d less than 0, obviously something inside the square root is negative, so that is complex number. So in this case, we'll have something like two roots, but these are two complex roots, two complex, or we can also say imaginary roots. And we can say no real roots, no real roots. Okay, so the graph will be something like this. This is your x-axis, and the graph will move like this if a is greater than 0. So it will not cut the x-axis, and if a is less than 0, the graph will be something like this, right? No real roots. So this is the concept of the discriminant, and let's just do some simple sums based on this. So let's say the question is, so let's say the first question. So it says find values of k for which the equation for which the equation 4x square plus kx plus 1 equal to 0 has two equal roots. Let's say this is the question, and we want the solution for this. So let's start off with the solution. So we know that d will be equal to 0 because two equal roots. So d is what? B square minus 4ac equal to 0. Now what is b? This is b. See, k. So k square minus 4a. What is a? A is 4. A c. What is c? 1. This is equal to 0. So k square minus 16 equal to 0. So now k minus 4, k plus 4 equal to 0. So k is equal to 4 or k is equal to minus 4. So this is your answer, right? Let's try one more question. So let's say now we have a question like this. Find values of k for which the equation x square minus 5x plus 9 is equal to k into 5 minus x has two equal roots. Okay. Now the only issue looks like is that this is a bit complex equation, not in a standard form. So I'll just make this in a standard form. So I'll just take everything on left side. So you take everything on left side and you end up getting this. You'll end up getting this x square plus k minus 5x plus 9 minus 5k equal to 0. See what I did, I just took everything on the left side and I got a x square term, I got a x term, and I got a constant term. So obviously my a is 1, this is my b, and this is my c. So now again I just have to do b square minus 4ac equal to 0. You put the values and you get the answer for k. You will end up getting k as minus 11 or k as 1. So you can solve this sum and you can check the answer if you're getting this. Okay. In case of any issue, you can just make a comment and we can just check that. Let's try one more. Let's say now we have something like this. Let's say the question is find values of k for which kx square minus 2kx plus 8 equal to 0 has distinct roots. Okay. So let's see if this is the question. So again, distinct roots, that means d should be greater than 0. So b square, so this is my a, this is my b. So now see b, what is b? B is minus 2k. Okay, remember the sign, and c is 8. Okay, so let's take this out. So we have minus 2k the whole square minus 4 a c, and c is what? Plus 8, right? So, and this is what? Greater than 0. So what you end up getting is you get 4k square minus, so this is 4 into 8, so 32k greater than 0. And now you take 4k common, so you end up getting k minus 8 greater than 0. And now you can just write this as k into k minus 8 greater than 0. Now we can use that VV curve method. So I'll just draw the x-axis and the roots. This is 0 and this is 8. So 0 and 8 hollow circle because this is not equal to 0. And as we discussed in the last lecture, anything after the root that is plus, then once you get a root, you change the sign to minus and then plus. Now, what we need is greater than 0. So where there is greater, here there is greater, and here there is greater. So that means k is less than 0 or k is greater than 8. This is your answer. If you want to write this in terms of intervals, you can write k belongs to minus infinity to 0 union 8 to infinity. Round brackets because it is not equal to 0 or equal to 8. So this was nature of roots, and this is very widely used in class 9, 10th, 11th, 12th, in JEE mains, and also in international board. So very widely used concept, very important concept, and in fact very easy, very logical to understand. Okay, so hope you like this lecture, and till next time, please take care of yourself. Bye bye.